Okay, good morning. Welcome to
FamilyMath193a.
FamilyMath193. Pull just a little bit away from there. Okay, so this morning we watched a little bit of Terry Tao's talk at the Museum of Math, and he's talking about how to measure distances in the universe. Have you ever heard Terry Tao's name before?
I don't think so.
Have you?
No.
He is a very famous mathematician. He won a Fields Medal, and which is an award they give every 4 years for the top mathematicians in the world. And one of the things he studies is prime numbers. So he did a lot of work understanding some of the prime number stuff we talked about a little while ago. So one of the things, I'm going to use his talk for a lot of different things to go into a little bit more detail. And we're going to talk about two things today. How the radius of the Earth got measured, and how the distance to the moon got measured, because both of those I thought were really cool, and they just used some basic geometry. Okay, so the first thing we're going to talk about is the radius of the Earth, and it was interesting to learn who was the first person to measure that. Do you remember who it was?
Aristophanes.
And what else did Aristophanes do?
Deceive the prime numbers.
He also studied prime numbers. So isn't that interesting? So Terry Tao is talking about Aristophanes. So he's telling the story about how Aristophanes found a well in a town in Egypt called Syene, or I guess he heard about it, maybe didn't find it, where one day a year the sun's rays come straight down into that well. Okay, so you can be the sun, and you can be the earth, and the sun's rays are shining right down on that well on that one day of the year. Now, these aren't particularly good models of the sun and the earth.
No.
Why not?
Well, they're the same size.
And they're squares.
Yeah.
Well, they're not squares.
They're cubes.
They're cubes, yeah. But that's fine. They're good enough for now. And he noticed that in the town he was in, which I forgot to write down.
Alexandria.
He was in Alexandria? Okay, great. That would be up here on the Earth, that the sun's rays were coming in.
They weren't quite overhead.
And he measured that to be a 7-degree angle. And one interesting thing you'll see in my picture here is in order to make this calculation the way Terry Tao's talking about it, is you have to assume all the sun's rays are parallel to each other. Which isn't quite right, because the sun's not this point infinitely far away. Are you the sun? It actually has size, and so the rays aren't quite parallel, but that's fine. This is a good enough approximation. For now. And now being 2,500 years ago. Okay? So he then came to learn that where he was and this well in Syene were 5,000 stadia. That was the distance they used back then, which turns out to be about 740 kilometers. Okay.
Yep.
Now, he realized if he knew that angle, and he knew this distance, and he knew that the Earth was a circle or a sphere, because Archimedes, I think, had figured that out. How do you go from this part of the sphere, this part of the circle, being 740 kilometers, to figuring out the whole circumference? What do you do?
You keep adding pieces on or all around until you get the circumference.
Very good. You keep adding these 7-degree pieces, and obviously I haven't drawn this accurately because it doesn't take 1, 2, 3, 4 7-degree pieces to get to 90 degrees. It takes more than that, right?
Yeah.
But we have to keep adding those 7-degree pieces until we get all the way back around.
So that means we have to divide 360 by 7, and that's how many it'll take.
Okay, so that means 360 degrees, which are in the circle, divided by 7 degrees is the number of wedges we're going to have.
Yeah.
Right? And then what do we have to do with that?
Then we have to multiply it by 5,000 stadia.
Times 5,000 stadia. And this should be 2 pi times the radius of the Earth.
Cool.
Okay? And then when you do that math, what did we get for that?
I think it was...
Did I write it down?
I think it was over there.
Oh, it's about 40,000. The radius of the Earth is about 40,000 stadia. Now, when I do the math, I get slightly different numbers than Terry Tao got, but it's all approximating.
Yeah.
Right? The important idea is here. how you figure out how many more wedges you need.
Yeah.
And you divide 360 degrees by 7, multiply that, and that's 2 pi times the Earth's radius.
Cool.
So Eratosthenes figured out that the radius of the Earth was about 40,000 stadia, which worked out to be about, whatever, 4,000 miles. And it was pretty accurate. In fact, amazingly accurate, given that...
Given their technology level.
Which we could approximate their technology level with what number? 0. So it's amazing. It's an amazing thing that they figured this out.
He was within 8% of being right.
Yeah, that's what he said, within 8%. Okay, so the next thing we're going to talk about is the distance to the moon, which is just a super cool calculation. Okay, you ready to do this?
Yeah.
All right.